In one of the last videos we looked at like the computational aspects to computing tangent lines and how they were related to the derivative function. So, in that video we looked at an example like a function that was given by negative x squared plus 2x. And in the last video we went through the process of figuring out how to compute the limit definition of the derivative for the derivative function. Okay, and then we took this derivative function and used it in the last video on computing what was called a tangent line. And we did all the computations behind that. And in this example, I want to just point out a little bit more of the graphical aspects of what we just covered. Right, so we can see here that since we have our derivative function of negative 2x plus 2, you can put in a variety of different values, say 1, 0, or 2, like this. And when you put those values into the derivative function, you get like 0, which is what we saw in the first example, or if you put in 2 to the function, we got negative 2, or you could even put 0 into the derivative function to get positive 2. So notice that we were getting 3 different numbers, and the question was what were those numbers representing, and we knew computationally that those derivatives were being used to compute the slope of the tangent line. So what we'd like to do in this video is to look at the function negative x squared plus 2x and change the point of interest x around from 1 to 0 to 2 and see if we can see what's happening. So here in this video we're looking at now a graph of the function that we were looking at before, negative x squared plus 2x. And that is the graph shown here in blue. Okay? Now this should be a quadratic function. It's a parabola that opens downward because of the minus sign in front of the x squared. So if we zoom out on this, it should look like a parabola that is opening down. Okay? And we should be allowed to move the point of interest around. And the red arrow is basically showing us the direction for your tangent line. If you were to lose grip with this function, that little dot, if we were to lose grip with the function at any point there, I say at that point, the particle or the little dot would go flying off in this red direction there. So what we're seeing here, for example, is at, say, 1, okay, there is our tangent line, okay? And if we show the rise over run, we're seeing that the slope of that line is 0. The line is flat, which is why in the computational video we got that the equation of that line was always y is equal to 1. Okay? If you move to a different point, I think we went to, say, negative 1. Okay? I'm sorry, 2. We went to 2. And the slope of the line is now a negative number. The slope, we're sloping downward from left to right. We can zoom out on this function. And the slope of that line will be negative 2. And that's what the table was showing us. Okay? If we went to the point 0 for x, okay, our line is sloping upward at that point. The tangent line, if we were following this function, and at time 0, if we lose grip with the function, we're going to go flying off in the direction of the red arrow. The slope of that line is 2, and we can compute the equation of the tangent line then using the red formula shown here. Okay? So that's all we're doing. The derivative function lets us take any value of x that we're interested in, anywhere along that line. And those numbers there that we can see changing, the slope, that is what the derivative function is giving us. So notice that at this point, negative 2.1675 for x. There's another number that we need to be interested in called 6.34. That 6.34 is the derivative of the function at the x value negative 2.1675. Okay, so that's just a quick video showing how the derivative function and the tangent line are related. The slope of all those lines, at every point the slope seems to be changing. The slope is getting less and less and less and less. And right at the top here of the function we have a slope of 0. And which side keep going, our tangent line is now sloping negative, which is why we can get some negative numbers for the derivative. So the derivative can come out to be 0, it can be positive numbers, or it can be negative numbers. And we'll have a lot more to say about that idea in future videos.